In this video, I will explain the following. First is applying properties of logarithms. Logarithms have various properties that can be useful for simplifying expressions or solving equations. Here are some key properties. First is we have the product rule. For example, we have log b x times y is equal to log b times y. This property allows you to rewrite the logarithm of a product as the sum of logarithms. Next, we have the quotient rule. It is simply put as log b x over y is equals to log b x minus log b y. This property allows you to rewrite the logarithm of a quotient as the difference of logarithms. Third is we have the power rule. Power rule. Oops, wrong spelling. It is simply put as log b is x to the power of n and equal to n multiplied to log b multiplied to x. This property allows you to move the exponent of a logarithm to the front as a coefficient. And lastly, we have the change of base formula. The change of base formula. It is simply put as log b multiplied to x is equals to log c multiplied to x over log c multiplied to b. This property allows you to convert logarithms with one base to another, base by using a common length logarithm base 10 or a natural logarithm base e. By applying these properties, you can manipulate logarithmic expressions, simplify them, or solve the equations involving logarithms. Next topic we have solving exponential and logarithmic functions. To solve exponential and logarithmic functions, you need to understand that the properties and rules associated with these functions. Here's a general approach for solving such functions. First is exponential functions. So first we'll focus to exponential functions. If you had an equation of the form y is equals to a multiplied to b to the power of x, you can solve for x by taking the logarithmic of both sides. For example, if you have 2 to the power of x is equal to 8, you can take the logarithmic base 2 of bottom sides to get x is equals to log 2 multiplied by 8 is equal to 3. Next is logarithmic functions. How do you solve logarithmic functions? If you have an equation of the form y is equal to log b multiplied by x, you can rewrite it in exponential form as x is equals to b to the power of y. For example, if you have log base, as log base 2 multiplied by x is equals to 3, you can rewrite it as x is equals to 2 to the power of 3, which is equal to 8. And lastly, the third topic is using exponential and logarithmic models. Exponential and logarithmic functions are widely used to model various real-world phenomena. Here are some examples. First, we have letter A, the exponential growth and decay. Exponential growth and decay. Exponential functions can represent population growth, radioactive decay, compound interest, or the growth of bacteria or viruses. The general form of an exponential function is y is equals to ab to the power of x, where a represents the initial value or starting quantity, and b represents the growth or decay factor. Next is logarithmic scales. Logarithmic scales. Logarithmic scales are used to represent data that spans a large range of values. For example, the Richter scale measures the intensity of earthquakes, and the decibel scale measures the intensity of sound. Logarithmic scales compress data, making it easier to interpret and compare values. Letter C, and lastly we have pH scale. The pH scale, which measures the acidity or alkalinity of a substance, is based on logarithms. Each unit on the pH scale represents a tenfold difference in acidity or alkalinity. For example, a substance with a pH of 3 is 10 times more acidic than a substance with a pH of 4. By using exponential and logarithmic models, we can analyze and predict real-world phenomena that exhibit exponential growth, decay, or have a logarithmic relationship. These models help us understand and make informed decisions in fields such as finance, biology, physics, and environmental science.